Good day, everyone. We are looking at another problem on the second moment of areas for mathematics. So the question reads, calculate the point of intersection of the curves y equal to 2x and y equal to x squared. Then we'll sketch the graphs and show the area bounded by the graphs. Show also a strip parallel to the x-axis. So you see I've underlined the most important things that we need to take note of. So my graphs are y equal to 2x, that's graph number 1, y equal to x squared, graph number 2. So we'll calculate the point of intersection. Here you see that the first graph is exactly equal to the second, since they all start with y. So that means x squared is equal to 2x. Whenever I'm solving for x, I must not make a mistake to divide by x, rather put everything on one side, equal to 0. X is a common factor. If we take out our common factor, that's what we get. So we get x as 0 or x as 2. If we now substitute our values into any of the equations up there, you see y as 0. If you put x as 2, you get y as 4. So therefore, our point of intersection are the point 0, 0 and the point 2, 4. So if I study those points of intersection, they all are found in the first quadrant, telling me where my graph should be found. So I'm going to plot my xy plane. I focus more on the first quadrant. So my first target will be to plot the point of intersection, 2, 4. So I can say this is my 2 on the x. Then I choose where I want my 4 on the y. So those are my points of intersection. So I can now study my graphs. Graph number 1 is a standard equation of a straight line. To draw a straight line, you need at least 2 points. I've got 2 points, so I don't need any other action. So I simply link the 2 to get my straight line. If I go to my second graph, that's a parabola. The equation of x squared is 1, so it's what we like calling the smiling face. So it should move like that. And it has only a single term, so if x is 0, y is 0. So the only point there is the origin. So I must sketch that to pass through the 2 points of intersection. So this is now the region surrounded by the 2 graphs. So now it's time to put the strip in the shaded portion. So here actually any strip could have worked as long as we know the strip should touch 2 graphs all the time. But the question says your strip must be parallel to the x-axis. The x-axis is horizontal. Anything parallel to the x must also be horizontal. So it means here, if we follow the instructions of the question, we must settle for a horizontal strip. So if I put my strip, I have to extend it to see which axis does it touch. It leads me to the y-axis. So the strip touching the y tells me that the formulas I will use for my area must end with dy. But another thing with the horizontal strip is that it also tells me how to label my graphs. My graphs must be labeled using x because your strip is parallel to the x-axis. So in such a situation, the first graph is found on the right side of the strip. The second graph is found on the left side of the strip. I must label them using x because my strip is horizontal, parallel to the x-axis. So if I want to know x1, I go to its original equation, which is the parabola, and make x the subject. That will give me y to the power half over y. Then if I want to see the second graph, it's coming from the straight line. The equation is y equal to 2x. If you make x the subject, you get x2 equal to y2. So I think with my graphs, I'm done. It's now time to calculate the area. So when I'm calculating the area, the formula I will copy from page 4 of my formula sheet as an N6 student will depend on my strip. If my strip touches the y-axis, you see I put my dy there to remind me that my formula must end with dy. So on page 4, this is my formula from C to D, x1 minus x2 dy. If my strip was vertical, it will touch the x-axis, then my formula will end with dx. So it's now time to put information in that formula. C and D, I read from the y-axis because my strip says so. My strip touches the y-axis. So I read from where I started shading to where I stopped along the y-axis. So I've got 0 to 4. My x1, you now see it on the graph, to be y to the power half. x2, it's y over 2, then dy. So when I integrate, I will have to add 1 to the power, it becomes y to the power 3 over 2 divided by 3 over 2 minus a half y squared over 2. So that's how my integration is done. The limits from 0 to 4. Then I substitute my limit. If I put 4 as the upper limit, I'm getting 4 to the power 3 over 2 divided by 3 over 2 minus 4 squared divided by 4. You see, 2 times 2 is 4. The lower limit is 0 minus 0. Since y is 0, if you put 0 there, everything will be 0. So what I'm left with is to confirm from my calculator what my answer should be. So I will take 4 to the exponent 1.5, that is the meaning of 3 over 2 divided by 1,5, then minus 4 squared is 16 divided by 4 is 4. So if I do that, I see my area as 4 over 3 unit square, which you can also choose to say it's 1,333 rectangle. So we are done with the area. It's that simple. Let's go to the C part, which says calculate the second moment of area about the x-axis. Sorry. For N6, you simply go to page 5 of your formula sheet. You look for the formula for second moment of area about the x. That formula will be written simply like this. So it's your duty now to develop this from your graph. What you do is that the axis written here is very important on how you describe r. So r is a distance. So to get it right, I'll go back to my graph. I start from the center of my strip in my diagram. I move in a straight line to the x-axis. So I'm doing that. Here's my strip, it's a horizontal one. The center is there. I'm moving in a straight line till I get to the x-axis. So if you look at that movement, it's a vertical movement. Anything vertical is described using y. So my r is a simple y. Therefore, r squared will be a y squared. So I'm getting my limits from 0 to 4 of y squared in bracket. My dA should be x1 minus x2 dy, just like you saw in the area. Then I can now open my bracket. Sorry, I can now put my x1 and x2. My x1 and x2 are still there. Y to the power half minus a half of y dy. Then I open my bracket. I will get y to the power 3 over 2. When you multiply this, no, is it 3 over 2? No, it's 5 over 2. When you multiply y squared by y to the power half, you add up the exponent. 2 plus a half is 5 over 2. Then minus a half. If you multiply this, you get y cubed. Then dy. Now it's time to integrate. You add 1 to the exponent. You get y to the power 7 over 2 divided by 7 over 2 minus a half multiplied by y to the power 4 divided by 4 from 0 to 4. Then we can now substitute our limit, starting from the upper limit, which is a 4. We'll get 4 to the power 7 over 2, or 3,5, divided by 7 over 2 minus 4 to the power 4, divided by 8. As you know, I hope you know where 8 is coming from. Then the lower limit is 0. If you put 0 everywhere, it's a 0. Then what you need now is your calculator to get the second moment of area. So I'll simply do that. I get 4 to the power 3,5. That's the meaning of 7 over 2 divided by 3,5. Then minus, I get 4 again to the power 4 divided by 8. That gives me 32 over 7. So 32 over 7. If you are interested in unit, it's u to the power 4. In maths in 6, we don't bother much about unit, but if you want to know how u to the power 4 comes about, you see the formula says dA is an element of area, so the unit is squared. Then unit r squared, the unit is also squared. When you multiply that, you get your unit to the power 4. So we can now look at the last part, which usually says express your answer in the C part in terms of the area. So what you simply do there is to copy your formula, your answer for second moment of area. You divide by your answer for the area, which was 4 over 3. Then you multiply by capital A. Capital A is representing your answer in terms of the area. Then you do that on your calculator. 32 over 7 divided by 4 over 3 gives us 24 over 7 in terms of area. Or if you prefer decimals, that's still fine. You will get 3,429A. So guys, that's simply how you get your second moment of area about the x-axis. Then you express your answer in terms of the area. Thank you very much.